So, can everyone hear me? Good afternoon. Thank you for coming today. I know it's right after lunch, so we appreciate everybody being here. We're very excited to talk to you all today about common security mistakes. So, both of us, we do a lot of work day to day on all sorts of web application, app exchange packages, all sorts of various things throughout Salesforce. So we're going to share today about these common security mistakes. We're going to share a little bit about them, how they happen, and then we'll go through sort of the mitigations that all of you can sort of put into your own code to avoid things like these happening. So before we get started, I'm sure everyone has seen this slide many, many times over the last 2 days, but Salesforce is a publicly traded company. So any forward-looking statements that you might have seen or heard about at your time here at DX, please remember, make all your purchasing decisions based on the things that we currently have today and not things that you've been hearing about that are up and coming. For the purposes of this talk, we're not really going to go through anything that's forward-looking. Most everything that we're going to be talking about is things that have been very well known in the security community for a while, and a lot of the mitigations have been in the Salesforce platform for a while. So before we jump into it, just maybe a little bit about ourselves. My name is Joe Trimble. I work on the enterprise application security team here at Salesforce. I spend a lot of time in my day-to-day working with internal teams and also with a lot of the vendors that we interact with. And really, as a part of sort of my day-to-day obligations, I spend a lot of time on trust and security for doing a lot of these reviews and also sort of being that champion amongst all of them for security.
Hi, everyone here. I'm Prashant Kannan. I'm a product security engineer. I manage security posture for one of the public-facing cloud. I do app exchange reviews and also build automation tools.
So we've broken this up a little bit today over all of the subjects that we want to get through, and we really have two high-level sort of topics that we want to drill down on. The first one is injection issues. If anyone here is building applications that take user input and sort of do something with that in order to have a more dynamic experience, the issues that we're going to cover, which is going to be cross-site scripting and SOQL injection, are definitely something that you want to understand, think about when you're building your applications, and definitely mitigate against. And sort of on the other side of the spectrum here, we're going to be talking about logical issues. So this is like functionality that you would build into your application that somehow ends up being abused because we didn't foresee that actually being used in the way that someone is using it. So in particular there, we're going to go through open redirections, and we're going to talk a little bit about cross-site request forgery. And so with that, we'll jump right in, and Prashant is going to kick us off.
Thank you, Joe. So the traditional computer security problem that has always been is trying to distinguish user input and computer code. The security vulnerability that usually happens is user input being run as a code. Some of the examples are buffer overflow, remote code execution, integer overflow, all fall under the same line. The similar issue happening in browser side is cross-site scripting. To give exact definition, user input executed as a code in a context of another user's session. So what happens in case of cross-site scripting is that the attacker here is able to inject script payload into another user's DOM. So if he's able to inject script, he can access the entire content which is there in that user's page. Probably, if, for example, if it's a bank account, he could access all the balances and all the details. And also the other thing is HTTP is stateless. The state is maintained by the cookie. So now, since the attacker can inject script into the DOM, he can also steal the cookie. If he's able to steal the cookie and send it to his endpoint, now he can do all actions as that user who is logged in. So for today, for cross-site scripting, I'll go a general cross-site scripting vulnerability in web application, and then I'll go into Salesforce-specific issues. So the three types of accesses based on how the attacker is able to inject the script payload is classified into reflected, stored, and DOM-based accesses. So in case of reflected, consider this. This is like a website called example.com, where a user input from the URL is rendered into the DOM. So now what an attacker could do is he could send an email saying, hey, you should probably click this link, or he can say, this is the new Game of Thrones season, it's out here, click this link, and the moment the user is logged in, probably he's logged into example.com, and then when he clicks this link, this user input is rendered in the DOM, and now this script get executed. Here it's just showing alert document.cookie. In reality, he could just send the cookie to his own endpoint by various means. So stored is another type. So in case of reflected, it happens through the URL. So the attacker puts the user input in the URL that gets sent. In case of stored, what happens is user input is everywhere. If you open Facebook, your name is an example of user input. It's there everywhere, even in LinkedIn or wherever you go. Everything is just basically user input. So this user input getting rendered in another place where there's a likely XSS sync, that will cause stored XSS. Let's see an example here. We have user details where I enter name, username, and email address. What if in the email address, if I put following a@a.com and then put that script payload, then that gets injected. Now, every other place where there's a likely XSS sync that opens up this email page in that DOM, the script payload gets executed. A good example will be MySpace Sammy Worm. If you have guys heard about it, that was the start of the whole XSS thing back in the days. So DOM-based XSS is becoming common now because of the client-side rendering model. So in case of the first two types, reflected and stored, the user input is sent to the server, and then the server responds with the DOM, and then when the browser is rendering the DOM, the script payload gets executed. In case of DOM, it happens completely in client side. Nothing goes to the server. So a classic example is here. So I have I have a hash here in the URL location equal to JavaScript alert. So in this, I have document.createElement. I'm creating an anchor tag, and then adding the user input to href. So here, when the browser is continuously rendering in the script context, it sees anchor tag, and then it opens href. It tries to open the URL that you click. Now it triggers the URL parser. Now when the URL parser is running, it sees JavaScript. Now the URL parser runs into JavaScript context, and the JavaScript gets executed. Let me show you a simple demo in Internet Explorer that I did in Lightning. I'll also explain why I used Lightning instead of other browsers in the future slide. So here I have a simple app. I take user input from the URL v.name. It's an anchor tag. So basically, I say click here for web page. So here, this is my help.salesforce.com. Whatever URL I'm putting in, I'm clicking here. It goes to click Salesforce page. Now let me try putting in a JavaScript here. I put JavaScript colon. I want to see what DOM it's executing on, so I want to see which page. Now the alert box will have, now when I click it, the alert box will showing, okay, this is the page in which it's getting running. Now let me try stealing the cookie. So let me try showing the current active user's cookie. So if I'm able to steal this cookie, then I can impersonate this user. I can do all action as this user. So this is an example. This is not possible in Chrome or Firefox. I'll let you know later. So now a simple fix for this would be putting a backslash. So this will prevent the URL parser from calling a JavaScript parser. Now it'll know it's going to be a URL. It's not going to be JavaScript anymore. So now if I put the same payload, I refreshed it so to make sure that I have the new state. Now when I click it, it's going to throw an error. The URL no longer exists. That's a simple fix in case of anchor tag injections. And now let me go on to next slide. So this mitigation is for any kind of web application that you're building. It's not Salesforce specific. In general, there are only two ways. One is input filtering. The second is output encoding. In case of input filtering, what happens is whatever input I get, before I store it in the database, I just do a whitelisting. If I see any HTML control characters, lesser than or greater than symbol, then I filter it out, and I allow only alphabets, numbers, and emails. In case of output encoding, what I do is I encode it into the context in which it's rendering. So if it's rendering in HTML context, then I'm going to use a HTML encoder. What it'll do is it's going to change the control character. Like if you see lesser than, it's going to be ampersand LT. So when the browser is rendering, it's going to know it's not a control character anymore. It's just basically a user input. So that's a good mitigation. The advantage of input filtering is that the moment you take in the input, you know that nothing, even when it's being stored anywhere, wherever it's getting rendered, it's going to be safe because you know you filtered all the control characters out. But the problem with the input filtering is that you now modify the user input. The user input could have control characters. Now you just filtered it out. So that's the problem with input filtering. And output encoding, the advantage is you will be able to retain the same input. You're going to store it in the same way. Only in the place where it's getting rendered out, you're encoding it. So, but the other problem with the output encoding is because you have to encode it in every single place. Usually, every single framework does it automatically, including Salesforce, Lightning, Apex, Visualforce. So another one, which is if you're building your own web application, you should know there's something called as browser's content security policy. So basically, you have unsafe inline script where you tell the browser if you see any other script other than what I provide, you do not run. You tell the browser that. So it's a content security policy which is supported by most of the browser except for Internet Explorer. That's why I was able to show that demo in IE, not in Chrome. If you see right-hand side, you can see the same bug that I demonstrated. I did it in Chrome. It propped up an error in my console saying, CSP is blocking it. This is something fishy. You should not do it. So yeah, but when we are building web application, we should consider users who are using IE also, because there are quite a lot of users who use IE in these days. So looks like this button. OK. Now, in Apex, we have two methods. TextUtil class has this escape to HTML. So whatever input you put in, it's going to change it into HTML encoding format. Similarly, if you're going to render in JavaScript context, that's there. Escape to HTML won't be required for you if you're using Visualforce in client side, because in Visualforce, everything that you put in HTML context is auto-encoded, so you don't need to worry, everything is taken care of. Except for two places, script and style tag. In case of script tag, what I can do is I could basically put here, I'm taking the current page param. I can just put a quote and then escape out, and I can put whatever script I want. And then that would be a classic example of XSS, even in style context to the same situation. So there are a couple of mitigations in Visualforce. So as I mentioned earlier, if it's in HTML context, the user input is there. You don't need to worry about it. The framework takes care of it. The other area that you have to worry about is JavaScript. Like if you're putting user input in JavaScript context, like I showed you in the previous page, you can just simply use JSON encode there. Then that will filter out all the ticks. So user, whatever script payload that he tries to put in, it will the tick character will be escaped out. And then URL encode is in URL context. If you're going to put user input into href or iframe URL, then that will prevent JavaScript in URL context. And the fourth case is very interesting. Now, if you see that on-click case, and I have seen web applications where people have used this case. So you have user input inside an inner HTML. This inner HTML is inside a JavaScript. So when the browser is running, first the JavaScript parser is triggered, and then you have HTML parser which is running. So you have to escape in both the cases. So to use that, we have JS in encode, which is going to first, the JavaScript parser, when it runs, it just ensures there's no tick. And then there's going to be HTML parser when it's run, everything will be encoded. So now Lightning uses HexHTML parsing. So Lightning, in a way, in case of XSS, is more safer compared to Visualforce because of the way it's been, because of whole client-side XHTML parsing model. Now, in this case, you can see all the other cases it's safe, except for two situations where you anchor tag and iframe, or when you purposefully use or unescape HTML. You just want to bypass the platform-provided encoding feature. So in that case, the demo that I showed, it won't work in Chrome, Firefox. It works only in IE. So when you build, you have to consider that in mind. So the simple fix is use a / there. And the other thing that we could have heard about is Locker, which Salesforce introduced after API 40. So Locker, in a way, reduces the impact of cross-site scripting. So what happens is it's like a JavaScript sandbox. So if there's only the JavaScript is restricted within the namespace. So if there's any XSS in, for example, the NS Finance app, then that script cannot access what's there in the weather app, and the script cannot access the document element because it's all restricted. It's like a JavaScript nice sandbox. Again, Locker is not supported for IE. It works in Chrome and every other browser. OK, now I'll hand it over to Joe.
So one of the main themes that everyone's probably noticing with cross-site scripting is user input. User input seems to be the bane of a lot of the issues that we see, and it's really going to be no different for SOQL injection. So I'm going to make an assumption, and that assumption is that most people probably have heard of SQL before or used it. Very, very popular, pretty much how everyone's interacting with with relational databases. And so we have something here at Salesforce called SOQL. And so there's probably, again, a lot of people that have either used SOQL or at least have heard of it. And SOQL shares a lot of similarities with your traditional SQL. And really, on the platform, you'll probably see a lot of those similarities, but you'll notice that SOQL has a much more reduced surface of what you can actually do with it as compared to something like traditional SQL. And there's a reason for that. And a lot of that reason that we do that, outside of making it sort of a seamless thing for all of you, is security. So real quick, some common things that we can go through here to sort of differentiate the two of them is that if you've used traditional SQL before, you've likely used inserts, updates, deletes, and selects, things like that. You've used unions before, you used joins. Well, the only thing that you actually are able to use when you use SOQL is going to be that select. You can read data, and you can get that data back. We can't execute commands, and we can't use wildcards. So if you were going to try and use wildcard on a field to pull back maybe all of the columns when you're doing some sort of a lookup, you can't actually do that. You have to specifically specify you want these fields from this object, and then maybe you've got some sort of where clause, and you can do some filtering on that. And the last thing really that maybe you've used before is actually chaining queries together. And again, in SOQL, we don't allow that. So we really have scoped that down to sort of, here's a couple of the things you can do, we'll get you data back, but we've effectively limited a lot of the damage that can be done if people start messing around with those SOQL queries. So injection, even though we've reduced that entire attack surface, it's still possible. So we still are taking user input. We might be putting it into some portion of a where clause. We might be using it as a dynamic field or an object. And so because we're allowing that, we still have the opportunity there for some sort of injection to occur and ultimately to get information back from the database that maybe you never intended for someone to ask for in the first place. So let's take a look at a quick Apex example. So in this example, we've got this Apex class, and we've got this function here, this method, and where search. So we're effectively allowing the user to input somewhere in the application this user input title that you see on line 11. We start on line 5 by building up that query. Basically, we want to pull back all the names from this personnel object. And then on line 12, we can actually see that's sort of where the injection itself could potentially occur. We take that user input title, and we concatenate it straight into the SOQL query. So we're sort of building the query up in different steps, but the end of it on line 13 is that we concatenate all of it, and we send that query off to the database. So because we didn't actually do anything to limit that user input here, we could ultimately end up in a situation like you see on line 16. What if what the user input wasn't actually looking for a title like manager or something like that? What if they actually sort of expanded on that query and they looked at another object in the system, performance rating, and they want to pull back everyone who's not doing so well? Well, because we didn't do any sort of filtering on this, any sort of validation, they absolutely could put that in, and what they're going to get back is a list of names from personnel, but specifically scoped down to who's not doing so great. So obviously, probably not intended when you were building the application, and it's definitely an information disclosure. So let's take a quick look at what this might look like from a user's perspective. So we've got this page here, and essentially, we want to allow user input to filter on title, and we want it to allow to filter by age. So we're going to come through, and just to look at what this might look like standard coming in, we filter on anyone who's older than 1 year old. And we get back this entire list of people from the system, and this is probably this is working as intended. So taking a look at the Visualforce page, we see that we have this input text, and we take that value, and we've got textual age there. So that's actually where we're storing that user input. And when we move over to the Apex portion, you can see that we have, again, that textual age, and we take it, and we actually, like we saw in the last example, we concatenate it straight into that query. So then we get that built up, we pull all into that database.query, and then we send it off, and that's ultimately how we got back that list of users. So what if we sort of change that up? What if we add on to this and say, okay, great, we want to look up anyone older than 1, and we also want to look up if they're a disloyal subject. Again, this is probably not something that you want anybody to be able to do, but when you perform the search, we actually get back all the people from the system that are greater than 1 year old and disloyal subjects. And again, most likely, more often than not, that's going to be some sort of information disclosure. So there's a few things we can do about this. Bind variables tends to be one of the more recommended solutions to this. Because we're dealing with putting user input in and not doing any sort of filtering on it, what we're ultimately confusing is what's the user data and what's the actual query itself. And that's the problem we're ultimately running into. So with a bind variable, we actually can let SOQL know, hey, this variable that we're passing into you, we really just want this to be treated as a variable. This is user data. It is not part of the query itself. And so you can see down there on line 27 and 28, we have our statement where we're actually going and we're taking a look. We're pulling those names from personnel, but we're throwing in a bind variable by putting that colon in front of Q title. And that, when we go and the actual SOQL query kind of goes and does its thing, it's going to let it know, hey, this is just data. So if we had put something like in that last example in there, it's actually going to look up that literal value instead of modifying the query itself. There is some limitation to using bind variables. It's not going to be available to you in practically everything you do, but we have some more details at the end of this where you can look up more if this doesn't work for your specific use case. The other thing we could do is write a sanitizing function. So in the event that you can't use a bind variable, we still have the ability to sort of take that user input and do some extra filtering on it. So in the case maybe you're doing a dynamic field or an object name, you can actually write a function and do some checking on that to make sure it's actually accessible, to make sure that it actually exists in the system, and only if all of those things are true do we end up actually returning that data back to the user. So like again, in this example right here, is safe object. If we imagine that someone passed in an object name and we actually want to allow that to be dynamic and do searching on that, we could run it through and say, hey, does this actually exist in the system? So we do get global describe, and then we check that that object actually exists. And then after that, we can check if it's actually accessible to the person that's requesting it, and if and only then they get that data back. So that brings us to the end of the injection portion. Now we're going to jump over to the logical issues, and Prashant is going to kick us off there.
Hey. So now, in case of open redirect, what happens is you're writing a code in such a way that makes the platform vulnerable to social engineering attack. So here, for example, we have a website called safewebsite.com, where what I'm trying to basically do is, after the user fills the form, I am trying to redirect the user to the home page of Safe Website. So what an attacker could here do is, he could directly call that URL on the onSafe. He could put whatever URL he wants, and then send that link to someone else. Let me show you here. So on the onSafe, instead of home/home/JSP, he could just put attackerwebsite.com, and he could send it as an email to someone. When someone opens up the email, they're going to see only the first part of the URL. No one looks at the whole URL as such. I mean, I have never seen. Even the browser also works in such a way that when you put in a URL, it's going to show only the main web page, and the other is not highlighted. So the user thinks that, okay, this is my trusted website, and then he clicks it, goes to another website within like a fraction of a second, and he enters the username, password, or it could be a page where it could ask for credit card information or other sensitive information. So in case of Apex and Visualforce, this is a classic example. So on onSave method, I'm just taking the onSave attribute, and then I'm redirecting the user to whatever that's there in the URL. So let me show you a quick demo here. So this is the website I have, and then the last one is prashantlakshman.com, which is going to be the evil website for now. So now, the moment I click it, it's going to redirect me to prashantlakshman.com, which is basically had a login page and information, but the browser prevented me. So here we have the username. Here I have the method which takes in the endpoint URL, and I'm passing it back and forcing the browser to move to that website. So some of the mitigations are hard code all the redirects. So if you know what are all the websites that the user should be redirected to, then by default hard code only those four websites, and you check if this belongs, if that input is one of these 4 websites, then do it. If not, then don't do it. And then you can have like local redirect, making sure it only redirects you to that with your own page, not to anywhere else. With this, hand it over to Joe, who's going to talk about CSRF.
So the last issue, cross-site request forgery, is definitely something that's common all over the web today. So if you've ever built a web application and you've sort of had to be responsible for cross-site request forgery, you probably know that there's some high-level issues that we'll talk about for how to fix this. But I think sometimes understanding what cross-site request forgery actually is it can be one of the toughest parts. So at the highest level, what is CSRF? Basically, it's a malicious actor, someone out there on the web who unknowingly to a user will get them to post some sort of HTTP request back to my site, your site, anybody's site that ultimately is going to modify that person's data without them ever knowing about it. And I think the forgery part is maybe the part that can be confusing for people, because I think everyone, it's understandable that you can make a cross-site request, that's fine. But the part that gets a little confusing is how can someone else force you as a user to make a request without knowing? And a lot of that really goes into the browser itself. The browser is doing a lot for us behind the scenes. Anytime it renders an HTML page and it parses through, it's actually looking at all those. It's looking for links. If there's images on there, it's actually going to go out. It's going to fetch that image. And it's doing all of that really behind the scenes without the user really having to know about it. So another part of that is ultimately how authentication sort of takes place on the web. So everyone's probably familiar with the standard login flow. You go, put in a username or password, something along those lines. The website will actually most likely set a cookie in your browser that contains that authenticated session, and then your browser will have that to ultimately pass back every time you access that site again, so they can identify you and you can do what you need to on the site. So the problem here is because the browser's trying to be good to us, it's ultimately going to record that cookie, and anytime it sees that web page again, it's going to send that back along, and ultimately, behind the scenes for the user, they don't have to worry about essentially providing that every time. In the case of cross-site request forgery, if you navigated away to another site while logged into potentially sensitive site like your email, and that site somehow makes a request back to your email to a piece of functionality that ultimately is going to change your experience on there, it all happens a lot of the time without you even knowing about it, because maybe it's an image, it loads that image behind the scenes, doesn't actually point to an image, points to that piece of functionality on the other application, and then ultimately we have cross-site request forgery, and something happens, and you probably don't notice until it's too late. So a quick visual diagram to sort of represent what we just talked about is we've got our user, opens up their browser, maybe is doing some sort of banking, opens up a different tab, decides they're going to go on their favorite news site, and as a part of that experience, they find this article that links them over to evil.com. On that web page, evil.com is basically going to have all the HTML that it wants to pass back to our user in order to read that article, but maybe in that HTML, we have something like that image. And that image, again, doesn't point to an actual image file. It points to a piece of functionality on bank.com. Now, when the user's browser ultimately renders that page and goes through and it parses and it looks and it sees that image, it's actually going to go try to fetch it. And ultimately, obviously, it's not going to get back an image, but it still makes that HTTP request to that site. And the browser, being a good citizen, says, great, we're going to send your authentication along with that. And then if bank.com is not protecting this scenario, maybe the user loses some money and they don't know it. Now, it's a contrived example, but it's the type of thing that we do see, and it happens often. And it's definitely one of those things that you might not be looking out for, but it can bite you, especially on more sensitive functionality. So let's look at what this could potentially look like. So right here, we've got this component. And our component, every time it loads, it's going to call this init function. So we see right there, we have the c.doInit. So the component loads up. It's going to call that. And that doInit function ultimately calls c.deleteAccount. So something in our Apex controller, delete account, is going to get called. And for this example, it's going to basically select a list of opportunities and just delete them. So if we go back and we take a look at what this could actually look like, we've got the initial page here, which is a list of all of those components of those opportunities. And just for the sake of looking at it, we have all the data in the system as it is. Now, what's going to happen is we reload this page with all these components on it, and it's going to call that doInit function, and we get back nothing because ultimately it just deleted all of those opportunities. So going back to sort of what we just spoke about, unknown to the user, if they had loaded a link like that and it had gone and fetched that page and that functionality had been written the way it was, it actually would have done just that. It would have deleted without them, having been a part of it. Maybe, again, it was loaded in an image and they didn't even see it load, but then when they go back later, they're like, hey, where is everything? That's something that happens and can happen quite often. So how do we ultimately mitigate against something like this? The answer for more times out of any is going to be randomness. We need to introduce something into these request flows that somebody trying to attack functionality and send these requests, they're not going to know about, and ultimately the server's going to shut them down. I'm sure people have used lots of common frameworks, Ruby on Rails, Django, things like that, and some of the different languages out there. They actually roll in this functionality for you, so you don't even have to worry about it. And a lot of the times what it looks like is when you authenticate and you get a session with the application, it's actually going to generate a random token, a CSRF token a lot of the times, as they call, and it's going to embed that on state-changing functionality. So anytime you're making a post request and you're changing information around on the application, it's actually going to send that token along to the server, and it only should be known by the client in the first place, and the server's going to validate it, and only if that's valid and you have an active session, it'll take the action. So if someone tries to stick that piece of functionality in, say, an image and load it up from a different website, they actually haven't sent along that random value that the server's always going to be checking for, and that helps to mitigate this type of issue. There's a lot of different ways people have done this, and a CSRF token isn't always the right way for your application, but more often than not, that's the way to go. And when it's not the way to go, we've got some resources for you where you can go and take a look at other ways that people have done this in the past and might be a right fit for your applications. As a side note, on the Salesforce platform, any post request that gets made is automatically protected for you, so you don't have to worry about that. But a call out here, any GET requests are not protected. So if you're doing state-changing behavior with GET requests, stop doing it. It's really, you shouldn't be doing it with a GET request to begin with. But if you are, just know that it's actually not protected for you by default. And that example that I showed you was actually an example of a GET request happening that's not sending along that randomness that we talked about, and that's ultimately resulting in these problems. So that brings us to sort of the end of the content. We do have a couple resource pages for you here. I think the first call out here is Trailhead. We have a whole trail about a lot of the issues that we've been talking about today, and there's even more in there. So if this has been interesting, you want to get some hands-on experience, definitely go check that out if you haven't. There's lots to learn there. And then for some of the things that we talked about, cross-site scripting and SOQL injection, we've got a couple links for you here. And it is probably worth calling out that we will make the slides available, so you don't have to feel like you have to get all this information right now. And then just real quickly, open redirects and cross-site request forgery. And with that's it for us, but we'd be more than happy to answer any questions if anyone has anything they'd like to ask.
Please ask your questions.
Oh yeah, and if you could please use the microphones if you do.
So in the cross-site request forgery,
yes.
Where is it storing that randomness? It can't store it in the cookie because that's automatically added.
Yeah, so normally it would be stored in the session. So like if you were to make the request to the page, and that page has, say, like a post request on there that you enter a form, like a sign-up form, or it could be like login, whatever, really. Ultimately, when you authenticate, it's actually going to generate that value and store it in the session, and then when you request the page and it returns the page back to you, it's taken that randomness out and actually embedded it as like a hidden field in the form, so that when the user goes to actually send that forward to the server, It's there, the server will process it, check it against that user's session, and say, yep, these match up. This must be the person that asked for it.
Cool.
Yep.
Hi, great job, by the way.
Thank you.
Thank you.
How does the Salesforce login page mitigate the ret URL redirect they have built into it?
Like what? Come again?
The login.salesforce.com has that parameter ret URL
Yep.
that passes to whatever page you were on before you got redirected to the login page. How does that prevent you from going to through an open redirect?
Oh, you're concerned about open redirect.
Yes.
Okay. So here we do not do we do not take the URL param from the URL and then force the user to that page. What we are basically doing is we'll authenticate the username and password, and our login server in the backend sees which server you belong to, which pod, NA54 or NA39 or EU, and then redirects you from the backend to that page.
Okay.
So it's basically like hard-coded. It's not taking any param from the user.
Thank you.
Yep.
Do you have any advice on how to develop user test cases on this?
Test cases. We have some automation tools like source scanner tools that we provide for customers. If you go to our booth, which is right near there, or after this talk, I can give you some details on how to access it. We'll run the scan for you and identify issues. But for test cases, I think you have to go through secure coding practice actually.
And actually, that's the last question we can ask in here, but we are happy to step outside or back to the security booth and answer anything else that you guys do have questions on.
Yeah, you can come over here, yeah.
Oh, hi. Good job with the demo. So my question is, do you have any tools wherein we can check the